Let's implement shadow casting for the light sources using Raytraced shadows. We'll add a new function, isInShadow, which will get two parameters, the light and the intersection. First, we'll initialize a result variable to false, and then we'll check if the light's base object cast shadow property has been set. Note that we're using the base object and not just the light cast shadow, because looking at the base object cast shadows is returning the state of the checkbox in the light base object. We can set it to true and false. Using only the node level cast shadow is going to affect the property in the node level properties cast shadows, even though a light itself cannot use this property. Max script doesn't know this and it sets the wrong property at the wrong level. We always have to specify the base object level in order to access the correct parameter. Now that we know whether the light is supposed to cast shadows or not, we're going to ignore the type of the shadows. We're always going to use Raytraced shadows. And at this stage, we can calculate the light distance. This is the distance from the intersection point to the light. That means the intersection 1 position. That's the position of the intersection point, and the light position, which is the position of the light source. We'll also build the light ray, which is a ray value starting at the intersection position and pointing at the light This is basically the vector from the surface position pointing at the light. Using this ray, we're going to perform an intersect ray X with every single object in the scene for all in the objects 2, and we'll perform a typical shadow intersection. Intersect. We can actually use the intersect ray function instead of intersect ray X, because we don't even need most of the additional data like barycentric coordinates, phase hit, and so on. We just want to know if an object has been hit or not, using the light ray that we defined. And now, if this shadow intersection is not undefined, it means that we have hit some object on the way, the current object O, and we'll have to measure the distance between the new intersection and the distance from the surface point to the light and figure out which one is bigger. If the distance, let's say distance from the intersection position to the shadow intersection position is less than the light distance that we measured, it means that some object is closer to the surface point than the light source, and the vector connecting the surface point and the light source is actually being interrupted by this object, which is exactly in the way of that vector. So in this case, we can say that the result of isInShadow is actually true, means we are in the shadow, and we break the execution of the for loop and force the function to exit with the result.